Welcome to Guitar.com Live. I'm Will Betts, features editor at MusicTech, and you're joining us for a discussion about innovation for guitar, specifically in the areas of AI and modeling. Now, AI is a term that's often used by marketing teams to make products sound more cutting edge, but our guest isn't from that camp at all. Doug Castro from Neural DSP has 50 developers behind him, he has a strong respect for academia, and he's also a bassist. Neural DSP is making guitar amp modeling plugins, but there's something a bit different about the way that they're doing it. They're genuinely using machine learning processes to make better amp models. And as we film this for Guitar.com Live, they're about a month away from the company releasing their hotly anticipated Quad Cortex, a floor processor that can capture the frequency and dynamic response of any rig in moments. We're talking all the way through preamp, power amp, speaker, and microphone. Now, this isn't the first time that a company has attempted this, but if their plugins and their process, which you'll find out about, are anything to go by, then this could be another leap forward for modeling. In this session, we'll talk about where we are right now, some of the exciting things that Neural DSP are working on at the moment, and how this machine learning technology could help guitarists in the future. So, thank you for joining us, Doug. I wonder if you could start maybe by telling us what your background is in this industry and set the scene for what the world of guitar amp modeling was when you came along.
Sure. So, well, first of all, thank you for having me. It's great to be here. Just a very, very quick background. I'm Doug Castro, as you said. I'm currently the co-founder and CEO of Neural DSP. Before Neural, I did another company called Darkglass Electronics, which is a bass-focused company. I founded and ran that for almost 10 years, actually. I'm still a shareholder. I'm still somewhat involved with it. A year and a half ago, I sort of stepped aside, and I was CEO of both Neural and Douglas for 1 year, and that was a bit too much, and that was before Neural kind of blew up and got crazy. So I'm kind of glad that I sort of picked one to run and put a really competent CEO in place to run the other. But yeah, I've been working as an engineer, creating products for musicians, technological products for musicians for a decade pretty much. With Darkglass, the emphasis was always in analog sound processing. So that's my background, actually. I'm an electronics engineer. Of course, now with Neural, the idea was to kind of like advance the state of the art, not just for guitar, but for music technology in general. And that's what we've been, working on pretty hard on since 2018.
Wow. So, okay, let's set the scene then. Guitar amp modeling, when you arrived, when Neural DSP was starting, what was the state of play with guitar amp modeling?
Yeah, so, I mean, there were a very great transformation had happened. I would say in the past, we started in 2018, so I would say that for the past, 5 to 7 years then, so I'm talking about, 2012, 2010, digital signal processing for guitar had become this sort of like cheap toyish, gimmick that kind of like entry-level users, bought to something that professionals used. And I think a big part of that was, companies like Universal Audio, Fractal Audio, Kemper, and then Line 6 with the Helix line. They definitely proved that, they proved two things. One was that embedded processors were powerful enough to handle, complex algorithms, and they also proved that algorithms could be created that would emulate the sound of an amplifier convincingly. I think for effects, it had been done already. Like almost all reverbs and delays were digital for a while, and widely accepted. Strymon, for example, has done some amazing work there. So, but I think when it comes to modeling the amp, which is kind of like the other than the guitar, is the second most important part of your voice, of your sound, how you express yourself as a musician. I think it took a lot of hard work, and it took a lot of really smart people to put that out there. And I think they did an amazing job at proving the world that that the technology was there, that we were ready.
And so, just before you carry on, can you tell us a little bit about there's a term you used there about embedded. What was it?
Sure. So it's embedded processor is just a processor that you have on a device that's not a computer, like a desktop computer or a laptop. So the the processor on your phone is an embedded processor, or any Internet of Things device is an embedded processor. And yeah, so those are quite, I mean, it can be tricky to develop for those. And I mean, it's hard for me to say. Analog devices who are the makers of Shark, for example, have been making processors powerful enough for a while, but just building a system that was, like powerful enough for you to be able to run several signal chains, effects, and amplifiers took a while. But yeah, I mean, I think the silicon, the hardware itself, has been around for, at least a decade, probably more. I mean, you have companies like Midas who have been using Shark for, many years and doing amazing things. So I think that the silicon was there. I think what it took was for world-class DSP engineers to create amazing algorithms that would convince people, and then it took these amazing companies to create these products that definitely showed people that you could have a great sound. You could have kind of like all of the conveniences of having a digital system, portability, versatility, be able to save presets with very, very minimum compromises. And so, just sort of where was the state of the art? So I think that was the state of the art then. And I think a lot of companies have done, not a lot, a few, but more than one, but less than 10, definitely. I would say a few, 3 to 5 companies have done a good job at recreating the sound of an amplifier very convincingly. Where I think things were, and that's 90% of how good it can be. I think, I'm just using these arbitrary quantifications.
Of course, that's fine.
The thing that we felt was missing was the dynamic response. Like, amplifiers have a very, very specific dynamic response and touch sensitivity. It's hard to express, but that's very hard to replicate digitally. So I would say that
it's one of those things as well, like among guitarists, like it's where I know I'm a guitarist as well, and I know that although you can get the frequency response right, that is relatively straightforward as I understand it. I mean, I'm no software engineer, so you say otherwise, but like the frequency response is the relatively easy part, and then the dynamic response is something else entirely. So why is that so difficult, the dynamic response?
I mean, so modeling things is very hard because you need to understand them extremely well for you to be able to model them. So actually, this is something that many people might not even think about, but the people who model analog circuits understand them probably a lot better than the people who created those circuits. I've seen this firsthand because, of course, we have done models of my circuits at Darkglass, my preamplifiers. These guys understand the circuit on a granular, like component by component level, in a way that I never even thought about when I was designing the products. I was just, trying things out, fine tuning things, of course, doing some research and learning in the process, but I never got into, how to, what does every single component do in the circuit other than, how does it sound?
Because I guess then what you're doing...
That is one thing. So if there's a part that is hard to, analyze, quantify, and understand, it's going to be really hard to model. And I think that dynamic touch is something that's been very, very... How do you design an experiment, to see where it happens? What we did was that we had a theory, and we just went with the theory, and sort of like write code based on the theory, and then sort of, saw where things happen.
What was the theory?
Sorry, what?
What was the theory?
Yeah, so I mean, again, it's my theory. So there might be a few people who understand T-bounce better than I do, and if I'm wrong, I'm sure the internet will not be shy to correct me. Basically, I mean, I hope I don't go too much into the weeds. I could talk about this technical stuff all day, but just to give kind of like a broad overview, you can see any amplifier as a modulator of the power supply that's controlled by the audio signal. So you basically have energy stored in the power supply, and then you have a load, which is a speaker in this case. And what you do is that you want to transfer energy from the power supply onto the speaker, but you can just dump energy because that's just going to sound like a big boom, or it's not going to be sound. It's not going to reproduce what you're playing. So what your guitar signal actually does is that it you can see it as a valve. It opens and closes the valve. So the flow of electrons, mimics the frequency, mimics the response of your instrument. And these are very complex signals. So it happens, I'm very oversimplifying it. But yeah, so what I think happens with tube amps, and again, this is just my theory, is that this energy transfer, of course, doesn't happen in 0 time. It's not instantaneous. Nothing is instantaneous in the real world. So what I think happens is that you have different, and the audio signal is a spectrum, right? So what you have is that the lower end of the spectrum actually has higher energy density. So you have more energy. The lows have more energy, are more energy dense than the mids and treble. So what I think happens is that the higher energy density needs more time to travel from point A to point B. And what I think happens is this effect in which when you play, especially if you are like distorting an amplifier, is that you'll hear the attack, like the mid and treble come first and the lows will come after. And this creates this like envelope effect that sort of, kind of like, it's like a nice kind of like foundation for the treble. So you can get something that sounds big, what people described, as big sounding, without it sounding boomy and overwhelming. And this kind of like envelope effect, it's really hard to reproduce. And actually that requires like very, very, very careful modeling of those parts of the circuit. But yeah, so that's our theory. And we sort of, that was interesting actually, and this kind of like circles back to the whole machine learning thing, is that we weren't sure how many of these theories were true, but we just kind of like went on with the modeling work and then just let the results, help us fine tune our reasoning behind them. And right, that part was very, very, very sort of interesting. And again, this is my theory, and I could be wrong, but I think we are onto something with this. And yeah, I think that's what causes this like very difficult to emulate dynamic response. And it's something that we've, focused a lot on neural and put a lot of, effort into replicating. So with 90% of our work has been trying to replicate, the last 10% that we felt, was trickier and very few or maybe no other companies that kind of like, got in there.
And so let's talk about the AI then. So what kind of AI are you using? Because there are various different kinds, and maybe just explain a little bit about why you chose this type of AI.
I mean, so actually, it'd be great if I could give you a story of this, like, epiphany or like technical insight. But it wasn't actually. It was more about the fact that we wanted to do quad cortex. And this was 2 years ago.
This is the foot pedal, right? The floor.
Sorry?
The floor. This is the floor pedal that you have. Yeah.
Yeah. So we went to do that, and we're already working on plugins. And it took us it took, one or two of our really capable engineers, people with PhDs, a master's degrees. It took them, a couple of months to do an amplifier. And we knew that for quad cortex to be competitive, you'd need to have at least 50. So the math just didn't add up, and we wanted to do this, within a couple of years. I wanted to do it within a year, which was impossible, but, within a couple of years. So, we don't need 10 years to do all the amps. So we are sort of like, I realized that we need to have a completely new approach to modeling amplifiers. And the only thing that can be faster than the best, and we had some of the best people in the world doing this. So the only thing that can beat the accuracy of a world-class, PhD in this area, and also can do it a lot faster is machines. And this is when sort of like we began recruiting machine learning people. And luckily for us, there were some people that had already done some work in this, like very theoretical, very academic, but they were on the right track, and we were sort of able to, partner up with them, bring them on board, and build a team around them.
So what does that mean? What does that mean exactly? You're talking about machine learning versus artificial intelligence. Maybe if you can just explain the difference there, and how does it relate? How does the machine learning then relate to?
The terminology is a bit, the joke here is that machine learning is usually done on Python, and AI is done on PowerPoint, meaning that AI is kind of like this buzzword that marketing people love to throw around, or CEOs when they're raising funding, love to throw around. Technically, machine learning is a subset of AI. So the definition of machine learning is just an engineered system that improves from previous experience. So it's able to learn, improve, optimize based on previous experience. That's what machine learning is. But actually, I was discussing this particular question with one of our PhDs in machine learning, and he was saying that although AI would encompass this, he said that there's theoretically ways to have AI without learning from the past. So even that definition is a bit iffy. And I think more than getting fixated on definitions, and again, more than we want to use AI for this, was like, no, we have a real problem, like a real world problem. What are the best technologies to solve this problem? And then, luckily for the marketing department, it happened to be machine learning, but it could have been something else, right? And then we had to create a whole new narrative around the company.
Yeah, could have been 5G.
That just worked.
So, okay. So what's currently possible with the AI? Because you're pointing the machine learning at different parts of these circuits, are you? Or what exactly are you doing with the machine learning? It's learning from what?
So, I mean, and we're always sort of expanding it. So, and this is also important to clarify, is that the neural capture feature is something that we had to very, very, very heavily optimize for the embedded processor for the sharks, to run on quad cortex.
So just before we get into that, can you just explain what neural capture is? Because people are aware of things like the Kemper profiler and other devices which can take a profile of a rig.
In principle, it's a very similar. It's the same type of technique, and the sort of the name of the approach is black box modeling, which is something that's been around for a long time. Black box modeling allows you to model a system without having any knowledge of the system itself other than its output. So in the case of an amplifier, you can send some signals, you can measure the output, and based on that, you should be able to recreate, or like if you're able to create a model of that amplifier just by reading the output, you have created a black box model of that amplifier or that system.
And is that to do with impulse responses then? Are you firing impulses into the system and then measuring the output in order to figure out what's going on in the middle? Is that essentially what it is?
Actually, our capture signal, so the signal in neural capture is quite short. It's around it's between 30 seconds and a minute, and it's a very complex signal, and it has like very, very different things. So the idea is to, in as little time as possible, generate enough training data so that the machine learning engine can actually, find meaningful patterns and recreate the amplifier's, sound and dynamic response accurately enough within, a few minutes. Actually, what we use for internal tooling, so, what we use in our plugins and for the full model, full circuit models of the amplifiers, or full feature models of the amplifiers, actually requires a lot more. So for that, I think we record hours of training signals. And actually in the room next to me, there's we bought it. It's a very, very, it's not, if I call it a GPU, I'm understating it. And if I call it a supercomputer, I'm exaggerating. So it's something in between, but it's like a computer that costs us tens of thousands of dollars. And it allows us to train these very, very complex models in a few hours.
So hang on. So you've got like this almost a supercomputer, like a fridge-sized thing full of processing cores, just chewing through this data of the complex signals you're feeding through these different amplifiers to build the perfect model, right?
Yes.
That's cool.
And neural capture is basically like a very kind of like pragmatic approach to that. I mean, the accuracy is very good. It's actually incredible for how efficient it is, but it doesn't allow you to learn control. So that's a part in which we need more powerful computers and more time to train them. So
what
we're
do you
talking
mean
about
exactly?
a very and we're using the sharks to do machine learning. So we're repurposing silicon that wasn't intended for this purpose in mind. I wish we could have added a GPU there. It would have made things a lot easier. And actually our machine learning team did an incredible job optimizing this. Like it looked, I mean, when they started, the capture feature was sounding amazing a year ago, but it took an hour to train on a very, very, very powerful, but consumer grade GPU, like a gaming computer. So I basically sat down and said, like, awesome, we are there, but now we need to make it, 10 times faster with a tenth of the processing power. So we basically told them that, yeah, you need 100x improvement on this. And like if you get a 10x improvement on anything as an engineer, particularly when you're at a very high level at the cutting edge, it's super hard to do. I mean, it's remarkable, but to get like 2 orders of magnitude improvement on something in such short time, it's almost unheard of. It's very, very rare in engineering in general. So yeah, they did an incredible job, and now it sounds great. It works great. It's fast. I mean, it takes less than 5 minutes, and it recreates your amplifier in a way that hasn't been done before for these type of approaches.
And so you talk about the previous those previous models being 90%, and you're trying to make up that last 10%, which is where the player is going, it sounds right-ish, but it's just not quite, it's not as good as the amp. Are you trying to close that gap completely?
Yes, I mean, of course. And again, my 90% was arbitrary. It could have been 98%, because I also think that the audience, or if you're listening instead of you playing yourself, it might be really hard to know the difference between, a previously existing model, like good model, and the real amplifier. Yeah. But I think when you play them, and there's something about the tube amps that just feel a certain way. And I think, and this is more of a philosophical thing, but at the end, the gear is not for the audience, man. The gear is for the musician. Like the audience, you can plug into almost anything. And in a big venue, if you're playing a stadium, nobody can tell whether your amplifier has new tubes or people can tell.
First gen pod into the PA. No one knows.
Exactly. It's very hard to tell, but you can tell, and I think that can make it the difference between how you perform. So. And again, like as musicians, we buy, nobody needs a second guitar, or maybe a second, but not a third guitar. And I don't know anyone who owns a guitar that only owns one guitar. Most of my friends and colleagues who own guitars own, multiple. It's not about being practical or pragmatic. This is just it's something that you want. And I think gear is the same way. I mean, when you get a new piece of gear, a new amplifier, a new pedal, and you go to play with your friends or go on a gig, you feel different. You have there's a sense of excitement. It makes things fresh again. So I think being able to sort of try to recreate all of that which the amplifier gives to the musician, but put it in a digital factor so that you can have thousands of or hundreds of amplifiers, and you can exchange presets with your friends very easily. Having all of the convenience without no compromise whatsoever was it seemed like a very interesting technical challenge, and a goal that was worth our time and effort. And I think also doing the capture feature, that was also very important, because again, I felt that what other companies had done was incredible and remarkable, but it wasn't there. And I think at the time it came out, or companies began offering this, it was amazing, and it was truly revolutionary. But nothing much happened since. So it's been 5-6 years since the technology has been popularized and become pretty much commonplace with musicians. And we haven't seen much progress, and that's a bit strange. Usually when a company is successful at something, either they keep pushing themselves and keep improving it, and that is something that I think me as a CEO try to do all the time, is never being fully satisfied, never being happy, and always trying to push ourselves, be better and do better products. But yeah.
Do you think there was an attitude at one point of this, we're close enough with this, and if somebody really, really, really wants it, then they're just going to buy the real thing?
Maybe. I mean, it's hard for me to speak for other people, and definitely don't want to do that either. For whatever reason, it was revolutionary, in 2013, 14 when it came out, and then since then there hasn't been much evolution. And it makes sense, because you need a new paradigm on how the technique works for you to do that, and that's actually extremely tricky to do. And this is one thing that is also important for me to sort of illustrate and remind people of, is that usually when you have a technical CEO like me, someone who's an engineer and also founded and co-founded and runs the company, the immediate thought is that this guy is some kind of genius that creates all these products, hardware, software, user interface design, cloud features, and also runs all the social media marketing and does all the PR. That's impossible. I mean, right now, I think our engineering team is over 50 people, 50.
Wow.
So there are entire teams of people with decades of experience in one thing, one or two things. And to do something like a quad cortex or a plugin or capture, you need, multiple of these verticals to come together. So yeah, it's definitely it's a big multidisciplinary effort. And I think one of the things that we had an edge on was that I've been very respectful and very I admire academia a lot, and particularly when you have projects like in physics, like CERN, for example, where you have like multidisciplinary physicists from almost every branch of physics, along with several branches of engineering, and all come together and do something amazing. I think kind of like one of the key insights we have was that if we were to, do the best there was at anything, we would need a lot more disciplines that were obvious at the time or that were obvious to our competitors. So having always an effort of being creative with the type of team we create and the profiles we add to the team and see how we have robotics engineers working in the team right now. Like
why,
right? But they've been amazing, and they've definitely enabled things that will unveil soon. But yeah, it's always just trying to find like the best minds in all branches of STEM fields. Mathematicians. We have a few physicists working on the team, for example, as well. People who have no experience with signal processing whatsoever, but they're very, very smart people who contribute in very unexpected ways sometimes. So definitely always try to make an effort in creating a remarkable team. A team that's comprised of remarkable people, and then basically once you have that, all you kind of have to do is set ambitious goals, goals that are very challenging and almost impossible. So these very ambitious type A personalities are driven and feel compelled to overcome these challenges, but are also doable, so that after a couple of years you can look back and say, wow, we created something beautiful here, let's move on to the next thing.
So what are some of those impossible goals you're sort of reaching towards? Because here we're getting towards the bleeding edge of what's happening in modeling for guitar amps. What are the current limits? What are you running up against right now?
So a very, very tricky thing to do would be to use capture for time-based effects or modulation effects. That requires it's not a new paradigm, but it's a very, very much more complex problem to solve than doing an amplifier with a cabinet or a few pedals together, like distortion pedals or EQs.
So are you talking about things like chorus, or are we talking about delays and reverbs, or what?
So I mean, actually, like a good next step would be compression, because if you can do compression, you sort of have capabilities to measure, detect, and learn time-based behavior, like attack and release times. Right. Once you have that, in theory, you should be able to expand that into much longer things, like having a 3-second delay. Reverbs get much trickier, but yeah, I mean, we're working on a lot of things along those lines, as well as completely new things. But yeah, with machine learning, it's like we definitely maybe need like a couple more people, because the team we have right now, it's kind of like we have like mini teams of like 2 people just working on things, and I think it'd be good to have a little bit more eyes looking at some of these problems. But yeah, I mean,
so what's the goal
like an
there,
obvious
then?
next step, though. Sorry.
What's the goal there then? To be able to recreate every piece of hardware basically from a studio or a recording rig, or a live rig? Is that the aim?
That is like, it's not the end game, but it's like a midterm goal, I would say, like with something we'd like to do within 2 years.
Okay,
I'm wrong all the time, but I remember when I started Cortex, I thought that it'd be like 3 guys and 6 months, and you have a quad Cortex, and it took 52 years. So I might be off. I'm overly optimistic sometimes with these things, and some of these problems are still like on the very, very early stage. So you're not close enough to the goal for you to be able to estimate the distance between here and then.
Sure.
But
this is why we're talking
in a couple
about
of years.
this is where we're talking about the future of AI in modeling, though, because this is, if you are having these ideas now, where are we? I mean, because we've got a lot of this technology in plug-in form, for instance. I mean, we've got very accurate recreations of compressors and delay, time-based effects, all of these things, EQs in our digital audio workstations. But what is it that you're planning to do differently then?
I mean, I think it's great that, within a couple of years we have become, one of the main companies known for making the best models of amplifiers in particular. It's kind of interesting to expand onto other, devices and other tools, so more like studio production. That's something that we're kind of like thinking about, not too much, but kind of thinking about. Where I think things become much more interesting is how can we leverage not so much the current technology, but the talent that created that into something much bigger than just being able to make the best sounding Marshall emulation. And we have like a pretty big, like really, really big goal around that. But it's too early stage for me to say much about it. But yeah, it's one of these things that I mean, this is kind of like interesting for me to explain also, is that people think that we're, like with Quad Cortex, for example, you're getting now a glimpse of what we had in mind 2 years ago. But we don't stop thinking about, like the years ahead. So sure. I think I really hope that, we can sit back again in 3 to 5 years and tell you, that when we talk, this is what we were thinking about, and now it's here. Some of these are moonshots, which I think is great to be able to take. And I think that's maybe also something that we do a bit differently, is that although we're very pragmatic with many things, and we are a business, so we need to create great products so that we can sell them and make money, so that we can pay great people, pay them well and everything. But we also do invest in projects that are very ambitious that might not pan out. And some things do not pan out, and that's okay. I mean, we tried something, we learned a lot of things along the way. Maybe some of these things can, open doors that otherwise wouldn't have been evident to us. But yeah, and I look forward to do more of that. So I think the better we do and the more we grow, the more chances we'll be able to take on pushing the envelope and, not becoming a company that's stagnant and complacent. I mean, if you look at companies like, I don't know, I mean, Apple is a very cliche example, but the Apple of, 1990 was not the Apple of 2000, and was not the Apple of 2010. So it's, and I'm not saying that I figured that out, but I all the time obsess about the concept of what did they do? What did the leadership do to keep that hunger and to keep that fire alive? Like in the way because in a way it's amazing when you're a startup, your biggest asset is usually is not, a key proprietary technology or I mean, sometimes it's a big part of what your strategy as a startup. But when you're starting out, the main thing you have that the others don't is new thinking. It's a specific insight. It could be knowing something that nobody else knows, or knowing that something's important before anyone else does. And usually what happens is that with time, you gain some traction, you build, if you're lucky, most startups fail. But if you are, in the whatever 10% that doesn't fail within a few years, it's very tempting to just do the derivative work of what you did first. So you you planted a flag with that original insight, and then you're just trying to expand on that and grow marginally.
And so what are those for you? What are those insights then? Because I mean, we're looking at the future. What are those? Is there an insight, or is there something where or are there technologies where you go, this is where this is going, and what can people be looking forward to?
Sure, there's a lot of insight. I mean, I think when it comes to sound, actually, like it feels like we're almost hitting a saturation point when it comes to signal processing and synthesis as well. So. And
what do you mean
we can
exactly
discuss,
by
at length why. But I don't think there are like big secrets to uncover or like big breakthroughs to, achieve when it comes to making a great sounding guitar. Like we've known how to do that for, 70 years now, or 60 years. But I think so. And again, we're talking that when we came in, we sort of had this intuition that, the field was 90% there. Let's work very hard to try to get it to, as close to 100 as possible. So in making a guitar sound good, for example, there was like 10%, room for improvement. And this is, again, arbitrary. But I think when it comes to user interface and user experience, there's definitely a 10x potential. So that's where I see the next big wave of new technology for musicians happening. It's, nail down the algorithms you want, create the sounds you want, but create user interfaces that encourage and sort of, make it easier for people to enjoy the experience and to people to actually explore and push the envelope. But it's not us engineers or product managers who are going to like push the envelope through our technology. I think it's going to be the users through how they use the tools we make.
It's funny you say that. That's one of those things where, on the Quad Cortex, I was, looking at the user interface of it where you've got the foot switches and they're also dials. Like, that's a really useful thing because these, they turn, right? Why shouldn't they be dials? And just little things like that. Does that come from is that your experience as a musician where you've kind of gone, is there an advantage there in being a musician rather than being somebody who's like, we're going to get into this business?
Oh, sure. All we talk about is gear and music. And when we go out after the office, for a beer or for lunch or for dinner or whatever, that's all we talk about. Like nobody talks about sports. Nobody talks about politics. Nobody talks about celebrities. Like literally nobody cares about anything other than engineering and music. And that's all we talk about. And that's probably not true for the entire company. Like we have some people working in finance who are not musicians. I'm sure that they have like much more, healthy
interests.
I don't know, healthy relationship with how they focus on things. But for 90% of the company, this is all we think about, and that this is all we really care about doing. So we're always trying to think about new ways to do better products for musicians, and at the end it all comes down to that. It has to be something that, like, the best technology that's not useful for anyone, it's usually worthless. Like, it has to be like innovation on its own. It's ridiculous. Like, true innovation has to be meaningful to the people who are using it. It has to make things better for them. It has to make them more creative, more efficient, or make things more affordable for them. If not, then what's the point?
And that's the question, I guess, with AI, is that can you use the AI technology to improve the user experience in some way, or to analyze what the common user experience and those problems are? Is that a way you can point that machine learning as well?
Yeah, so actually, you kind of nailed it, actually. So I think a big part of, because as I mentioned, the internal tools we have, are much more powerful than what the users can use, and that's just because if we sold a product that requires a $30,000 computer, then we wouldn't sell too many. But we are trying to kind of like bring some of that power to the users in ways that are not related to amplifiers necessarily. But yeah, I think you can nail it in that the benefits that we've been able to have through being able to automate something that took us 2 months into something that takes us 2 hours. I think there's a lot of opportunity in being able to do that for people creating music. So how can you help them automate things so that they can focus on the fun, creative part, and everything else can just be, delegated to a machine that can do things much more efficiently than you can. A machine that doesn't get tired and doesn't get bored, but that is not creative either. So I think that's kind of where the new frontier is.
Are you saying sort of Siri shortcuts or Siri suggestions for tone? Is that kind of where you're going with this? Like,
actually, that's an interesting. We thought about something like that, but it wasn't. We've been discussing recommendation algorithms for Quad Cortex, and this will come in handy once we have hundreds of thousands of users, and there's millions of presets floating around. And it's how can we help people sort through this ocean of options, and help them find the best and what they want. So yeah, we thought a lot about that actually, and I think that's definitely an interesting thing to do. And you can do a lot actually, because once for example, people's signal chains, you can infer pretty accurately what kind of music they play, for example. So if somebody has a tube screamer with a dual rectifier, chances are they're not playing, like classical guitar or country music. They're probably playing, hard rock or heavy metal, right? So I think if you have, lots of presets, we can definitely kind of like get better at suggesting things that, you'll find interesting, that you'll want to explore. But this is just like a theoretical thing that we have for the future. It's not something that we're truly working on yet. There's a lot of work we need to do now so that we can get to that point. But that'd be quite fun to do, actually.
And what's the absolute biggest moonshot that you can conceive of where, 10 years, 15 years, 20 years down the line, where is this technology going to be? What do you expect it to look like, and what do you expect it to be able to do?
I really can't say. I hate to give this answer. It's too early to tell. It'd be responsible from both a strategic and also a managerial point of view to put it out there, because it's something that's quite ambitious, and I have no clue whether we can do. I have no clue, whether anyone can do it. So I'll leave it there. I hope again that in 5 years we can sit again and tell you, this was the thing. But it's pretty big. When the company started, I'm going to give a clue, so you might be able to find it on your own, but most likely you won't. When I started, when we started the company, and this was before we were operational, so late 2017, I did a website. I did it myself. And that website was designed to recruit people. So there were no products because we had no products. There was no team because me and my partner were the team. But what we had was kind of like a master plan, a mission statement. It wasn't, like a MBA, bullshit mission statement. It was, this is what we're going to do. Step 1, step 2. We're actually now at step 2, but there was a step 3 and 4. Actually, there was no step 4. I came up with that later on. But yeah, there was a step 3.
This is all very mysterious. This is super mysterious. Well, you got to give us some more information. Come on.
This mission page has been deleted from our site, but you might be able to find a screenshot somewhere. But yeah, it's definitely related to automation. So it's able to. It's give people it's empower musicians through very, very, very powerful automation. I'll leave it at that.
Okay, well let's think a little bit then about guitarists. There is the detractors in the world will say that certain guitarists can be a little bit technology averse. I mean, it's a field that has. I mean, apart from yourselves and all the other modeling companies, that it's very traditional, and these are circuits that many of them haven't been improved upon or developed for a very long time. Have you ever sort of run up against these people who are coming to you and saying, nah, we don't need it, like we don't want this?
Sure, there are, and I think that's great though. I don't see any problem with that. I always think that musicians and car enthusiasts are quite similar. So I think you can learn a lot from the, auto industry and the users. Very tribal, very I'm a Mustang guy and I'm a Mustang guy, right? Or I'm a Tesla guy and I love Tesla.
Sure.
I think with that metaphor, we definitely want to be Tesla, but we don't want to convince, people who love their muscle cars to buy a Tesla. It's
sure.
You have your tube amps, you love them. Who am I to tell you that you shouldn't? By all means, have fun, enjoy. I think we want to create products that are appealing to people. And if we don't manage to lure you in, it wasn't meant to be. You can't make everyone happy. And we're not trying to convince people that will never stop using amps to stop using amps. Amps are perfectly fine, and they're great people making great amps. I'm good friends with many of them. My other company makes analog amps. So I have nothing against analog gear. I think it's just a different it's a different solution to a different problem, and that's great. There's nothing wrong with that. Where I do think we can do some work is in the people who are, like at the verge of making the transition. So I think a lot of people want the convenience, want all the kind of like all the benefits, but and this is one of the things that we wanted to change also. Like, to us, it felt that especially when we started, you as a musician, if you wanted to go for a digital solution, in hardware, like a modular device, you kind of had to choose between user friendliness, intuitiveness, ease of use, and power. So if you wanted to sound, if you want like the proper sound and as close, really high quality modeling, you also had to deal with a lot of complexity in how to set things up that, wasn't necessary. And it felt like the devices that were, more easy to use sounded like crap. So why is that? Like, I mean, we really asked ourselves, is do you need that? Can you have one without the other, right? Can you have the best of both, or can you have something that sounds the best but it's also the easiest to use? And quad cortex is our answer to that. So I think there's a lot of people who have kind of like not, stuck to analog gear just because it's more intuitive and self-explanatory, that I hope we can sort of convince to, try out once quad cortex is shipping. But then again, a lot of people are just happy with amps, and that's great.
Cool. So happy for there to be a sort of a broad church. You're not going to start telling anyone to get rid of their gear or anything like that. It's reassuring.
No, I mean, all we can do is to create products that we personally, are proud of, and that we think that musicians will love. But it's like with relationships, like you can't force it. Like if somebody doesn't like you, or if somebody doesn't love you, there's nothing you can do to change that. It's like I mean, you can try a new product and see if you can cater to them. But again, like we're not in the business of converting people to a new paradigm. I mean, I think we try with our products, but if our products don't do it, then that's all right. I mean, we'll continue to do more products, so maybe the next generation of things might, but maybe it won't. I think with some people it'll never. Some people will use amps, till they die, and again, I think that's great. I personally, if I mean, it's very self-serving for me to say, but if it wasn't for something like quad cortex, I would have been one of those people too, because I did not want to deal with the hassle and complexity of having to read a 400-page manual to turn on the delay or to add a compressor. That's not me. So I think yes, what we want to do is something that's as self-explanatory as creating an analog path where you connect the pedals and set the amp dials. And I think also like having the foot switches be the knobs, that was important, because I think there's something to the tactile experience of moving. Like, it would have been super easy for us to just use a touchscreen, right? Like, it's a 7-inch touchscreen, but
like a lot of competitors do that too.
You can do it there too. Like you can either do it from the actuator or from the screen. But there's something to that experience, man, of like just turning a knob and having the volume go up or the gain go up or whatever. That's important. And I think these little things, it's all about the experience at the end. It's all about people enjoying the experience of playing through the gear. And we didn't try to replicate kind of like the experience of playing analog gear. I think we tried to kind of replicate the simplicity and intuitiveness of it. But at the end, I think we want to create a new experience in itself. And I hope that we create an experience that people prefer and gravitate towards. We have pre-sold a ton of them, so things seem to indicate that we're onto something here. But at the end, time will tell. We'll ship a few thousand of them, and if people love them, which we're working very hard to make sure they do, we'll get to ship a few more thousands of them and continue to build on it.
So these are not yet in people's hands then? This has not yet come out?
Yeah, we're gearing up to begin shipping next month, so this would be November. We have the factory, running double shifts and working pretty much 7 days a week, double shifts here in Helsinki, actually. So trying to make sure that we can go to November with a few thousand units built and good to go.
Excellent. Well, it's a very cool thing, the quad cortex. It's very exciting, and we look forward to hearing about more of the future of AI with you guys, with Neural DSP. Doug, thank you so much for coming on. This has been an interview for Guitar.com Live. I've been Will Betts. You've been Doug Castro. Thank you very much for watching. See you soon.
Thank you. Bye.